Hi, I am Ahmed Daud, and in this session, we are going to see model building. In the last session, we have done with the EDA part. So, here we will see model building. So, first of all, we will see what type of wrong predictions our model can do. There can be two type of wrong predictions, false positive and false negative. We know these times theoretically, but here in our case, when our model predict a customer is not going to default, means when our model predict for some customer risk is equal to zero, okay, but in reality customer will default, then there will be a loss of resources. Okay, let's say if our classifier, our model will predict that customer is not going to default, and actually he will or she will default. But on the basis of our prediction, if the loan manager has issued the loan to that particular person, to that particular applicant, then there can be a loss of resources because our model has done wrong prediction. So, secondly, if our model predict a customer is going to default, but in reality the customer will not default. Our model have is predicting here that customer will default, risk is equal to one. Okay, but actually in reality customer will not default. On the basis of the prediction of our classifier, our uh, loan manager will not issue, will not approve the loan of that given customer, or that particular customer for which our model has predicted that he or she will default. Okay, in that case, we will lose our potential customer who actually will not default, but our on the basis of but our model is saying that he will default. So in that case, there will be a loss of opportunity. There will be loss that we will not earn the profit or revenue that we can earn from that customer. So which loss is greater? Loss of resources. There can be two type of losses: loss of resources and second loss of opportunity. So which loss is greater? Loss of resources will be greater loss as the bank will be losing their resources. For example, if bank will earn profit or interest 10,000 on the loan of 1 lakh, okay, but in the case, let's say this is the scenario. Usually if bank earn interest 10,000 on the loan of 1 lakh, now if there will be false positive, our model has predicted that this customer will default, but actually he will not, then our bank will lose 10,000 profit in terms of that he can earn from its from their potential customer. But if our the case of false negative, then the loss of 1 lakh resources. If our model has predicted that this customer will not default, but actually he will, then our bank will lose 1 lakh that he has our bank has given to that particular customer on as a loan. So here, which loss is greater? False negative. So how we can reduce the loss? Fast negatives you have learned. There are different measures, and each measure have some speciality. In which case we should use. You can recall use the recall here as a measure, because recall, when you are more sensitive about the fast negatives, you can use recall. So here we will focus on the recall, that we should have high recall. Now, keep in mind, high recall does not mean that you will have very bad precision. You should have high recall and some good precision also. But here we will focus more on high recall to reduce the false negatives, to reduce the major loss to our bank. Okay, so as in the our case study, in our problem statement, it is not mentioned that this percentage of recall they want, they have a requirement, as it is not mentioned. So we will go towards the optimal recall that we can uh, achieve here. Okay, so as for the our data is this one we have here, our data set in which 1000 rows and 10 columns. Now we will split this data set into the independent and dependent variables so that we can pass to our model for the purpose of training, testing. Okay, so here independent variables x, y will be dependent variable. Second, now we will convert here our categorical variables, categorical columns into some numerical columns. Okay, so what are categorical independent columns? We have these number of about six columns. We have categorical columns. So we will get one hot encoding. We will convert these columns into some dummy columns, and you know the purpose of that model will or model will not deal or cannot deal with the categories, with cannot deal with the strings. Model always deal with some numerical values, so that's why we are converting here. So by using pd.get dummies function, pandas dummies get dummies function, we will pass here our x, which is independent variables here, and columns that uh, we want one hot encoding for that these columns. And here I am specifying drop first is equal to true. What actually it means that if our sex, in the sex column there are two categories, male and female. Okay, so if there are two categories, then we want k minus 1 dummies out of k categorical level. If there are two categories, so we want one column for that. Okay, what actually it means? It means that here we have converted our six columns, uh, five columns into dummy variables. So you will see here sex has two categories. So here it is converted into one column. As it if I will not mention draw first is equal to true, then it will convert that sex column into two columns according to their categories. Okay, but here I am specifying that drop first column should be dropped here. Second, housing have three categories actually, and here it is converting this column into two categories. Why it is doing that? Because here in the sex male, let's say, if the sex male will be 1, then it means that it is male. If it is 0, then it is obvious that it will be female. So we don't need to have another column with the sex female. Okay, 0 can represent the other category also. In the same way, when the housing 1, it means housing on. When here there is no, we can see, but in when both are 0, housing on and housing rent both are 0, then in that case it is actually representing the third category, which is housing free. Okay, so for that case, that 0 can also represent some other category. So that's why here, instead of k number of columns, we have converted our categorical columns into k minus 1 number of columns. Okay, so why we have used here three columns here, five columns instead of six columns. Here I have skipped one column, which is job. I have skipped that column just because of the reason uh, that I want to convert that column into the four categories. Okay, here I am using job. Now I am converting my job column into dummies, and here I am not specifying that row first is equal to true, because in the data set we have three categories. Okay, but actually job have four categories. So if we will drop this job with the job, we will drop one column, then it will have two columns. Okay, but actually it has in the problem statement it has four categories. So it should have three columns, either so that when all of three columns will be 0, it can represent the fourth category also. So that's why here I am separately converting my job column into some numerical column. Okay, here you can see job have three categories actually. So I want three columns for job instead of two columns. The reason I have told you that if there will be all zeros, as in that particular data set there is not all zeros, there is no fourth category, but if there will be fourth category, it can cater, okay, in the form of all zeros. Okay, I hope you got this enough. Like here, we have in our data set these three categories, and there is also another category which is unskilled and resident. Okay, so now we have done with our data set. We have now independent variables separate and dependent variables x and y. We have converting our categorical columns into some numerical columns. Now our data is ready to go further for the further process. Further process will be the we will split our data set into train and test part. Here I am splitting my data set, and here you can see the shape in the with the percentage of 30% will be for uh, test data set, and 70% data will be used as a trained data set. And here you can see the shape. Now instead of just 9 columns, we are having 21 columns in our independent variables. Okay, so 700 rows in the training data set and 300 rows in the test data set. Okay, so here I am using here the creating a variable which contain the names of the continuous variables. There are three continuous columns in our data set. Okay, so I am doing a standard scaling. The reason for why I am using standard scaling, it's not purpose to remove the outliers or to dealing that type of case. For that I am using a scaling. It's not, and it is also not for the for improving the performance of our model, because standard scaling cannot remove the outliers also, and it just shift the data. It cannot help in the improvement. It cannot have a significant impact on the performance of the model. Then for what purpose I am using here standard scaling, so that I can scale my three continuous variables on the uh, zero scale, uh, or you can say mean scale. It is actually standard scaler. And all the other columns in the independent variables, about 18 columns we have, all have one and zeros in values. Okay, and this in this like credit amount can have very high values in the form of thousands. Okay, so I am decreasing the strength of the values, so that uh, we can discuss the coefficients that we will obtain by after training of our model. We will obtain some coefficients, so that we can talk about, we can interpret the coefficients. We can see that behavior of the columns, the strength of the relation of the independent columns with our dependent column. For that case, I am making all the columns on the same scale. Other 18 columns are already on the 1 0 form. These three columns have different values because of different units. Age has unit of years, credit amount has a unit of DM Deutschmark, and duration has a unit of months. So I am scaling down on the by using standard scaler to make these variables on the same scale. Okay, so here I have converted my continuous columns by using standard scaler, both training data set and test data set both. Now the third part here, hyperparameter tuning. What actually it is, I told in the start also that this part we will explore in the coming modules in more detail. But for now, I can tell you here, like here in the case of logistic regression, there can be multiple solvers. Okay, like five solvers, there can be two penalties, there can be different values of c. So what values should be used here in against these parameters? Okay, there can be question. You can also decide by yourself what value you should use, uh, and some most of the time it is not give you a good result, because already you are have not learned the pattern from the data, that you have not so much you can say ideally intelligent, that you can understand which value can be best for that model. For that reason, you will train your model. You will train your model on multiple combination of values, and which values are giving you the best score, you will use that values for your model. Okay, this process we usually call as hyperparameter tuning, that you are selecting your parameter values, what values can be best for your parameters in that particular case of data set. For that reason we use here, let's say here I am using, let's say this C. If I will show you, I am passing here in the case of C, yeah, this number of values 0.007, 0.017, and if I will see the length of that array, yeah, there are 50 values in this C, okay, which is you can see from here. If I will plot again here, I will print these values here, and you can see these C values, and you now C actually control the strength of the penalty that we are adding in our models cost function. Okay, so these values different about 50 values against the C parameter. Against the solver, there are five solvers, and against the penalty, there are two L1 and L2 penalties we have here. Here I have created a dictionary of the parameters. Now what will happen when I will use a grid search CV here. I am passing logistic regression by mentioning the random state tolerance. I have decreased here instead of default tolerance, which is 0. Uh, 0001. I am using here 0. Tetra 01, and I have also increased the maximum iteration from 100, default 100, from 100 to 1000. Okay, here I mentioned the model that I want to use, the parameters. These are the parameters in the form of dictionary, and the scoring that I want to see is ROC area underscore undercar. Okay, now I am fitting that classifier, which is grid search CV actually, on the X train and Y train. What it will do, it will generate the combination of all values. Let's say in the case of 0.01 linear L1. This will be one combination of values. It will pass to that logistic regression, train that logistic regression on X train and Y train, and it will calculate ROC score for that. In this way, for all about 500 combinations, it will generate. This will generate about 500 combinations because of CR 50 values of C multiplied solvers are 5, 250 multiplied by 2, there will be 500 combinations of values can be here, and against each combination of value there will be a training of one logistic regression regressor, and against each trained logistic regression there will be calculate ROC area under curve score for each logistic regressor, which parameter values will give us the best score, ROC under curve score. We will use that parameter values for our model. Okay, so here we are selecting the best parameter values for our model, you can say, by using grid search CV. Okay, here you can see it has tried all these C values, all the penalties, all the solvers. Okay, now this classifier dot CV results, so we can see the results also. I have converted the results into data frame so that I can show you here. This data set has about 500 rows because there are 500 combination, and against each combination there is one model is trained. So here let's say the first sample, which is 0. Here our model are having 0.007 C score, L1 penalty. Here it is using linear solver, and these parameter values are used here. Against these parameter values, it has these are the split. Okay, and here you can say this has 0.5 a ROC area under curve score. Okay, in this way against each value there will be area under curve score, like here 0.67, 4068. This score is against these parameter values. Okay, and you can also see there are n values just because there are due to uh, due to not compatibility of these parameters. Okay, parameter values, because here you can see in the, let's say, like in the Newton CG is just you can use that solver in when you have L2 penalty or no penalty. But here when there will be combination when you have penalty L1 and solver Newton CG, then it cannot work. It cannot train. You cannot train that type of model. You cannot have such type of model which will have L1 penalty and Newton CG solver. Okay, so that's why there is n values in that data frame. Okay, so in this way there are 500 that uh, logistic regressors are trained here. Against each there is some area and a curve score. So if you want to see the best parameters, it will print the best. If you will use that classifier, and that classifier dot best parameters, you can explore grid search CV documentation by, let's say here, if I will write scikit-learn. Okay, so here this is the grid search CV documentation, and you can explore that there are parameter values, there are some attributes, arguments, sorry, methods that you can use. Okay, here this CLS, which is grid search CV dot best parameters, it is telling me that 0.07 penalty L2 over linear. These are the best parameter values for our problem statement in case of our data set. Okay, and how it has evaluated on the basis of best score, which is this one, 0.668 approximately. Okay, so now by using these parameter values, I will train my model. Okay, now I will have a model which is logistic regression, having 0.007 parameter value for the C, maximum iteration 1000, tolerance 0.tetraf 04 penalty L2 that we have here figure out which should be the good penalty, and linear solver. Okay, we have now till now uh, we have estimated the best parameter values for our model. Okay, and if okay, so you can question, you can have this type of question that if we have to select the parameter values just by iterating this type of loop or this type of using the grid search CV function, so why we should need to study these documentations, the concept behind each parameter. Now the reason is that if you know about these combination, you can you know about these parameters, you can have an idea that which parameter is more important. Let's say if you will pass here max iteration also here, and you will also generate max combination when the maximum iteration is 100, 102, 103 up to 1000, there will be thousands of combination can generate here. Okay, but you know that what actually the concept behind maximum iteration, the concept behind maximum iteration is to just iterate the gradient descent process. Okay, gradient descent algorithm. So instead of passing different values, we cannot get a good result. It's seems like you can say ridiculous that if you will use max iteration and different combination of max iteration here. Okay, how you get to know that max iteration cannot be used here, different combination of max iteration cannot be used here, uh, because you have the concept behind the max iteration. In the same way, you know about the tolerance, so the values you know about the tolerance, maximum iteration, you already have specified. You have not gone in the here you have not generated the combinations for that these type of values. You have not tried to find best values for these parameters. Okay, you already know these strength of the penalty, solver penalty. These are the most important parameters, so we should find the values for these parameters. For that purpose, you have to use the grid search CV. Okay, if you know the concepts behind each parameter, then you can understand that for which parameters you have to find the value, because if you will against all the parameter values, all the parameter values, you will generate a dictionary, and against all parameter there will be multiple values, and you will train model against each combination of values. Then thousands or sometimes lakhs of models you have to train here, and it will take a number of days to for the training process. Okay, and it's also uh, it's not a good practice here. Okay, so here you can also get the idea why the concepts behind the parameter values is important. Okay, so in this way we have selected our parameter values, and we have here created a model instance of logistic regressor, and now we are doing our training on our X train and Y train. Now this model will be trained on X train and Y train, and here this model has these number of coefficients. Okay, against each like 21, we have 21 independent variables, so this will be, these are the 21 coefficients we are having here. Okay, so I am creating an instance of log of odds ratio. Okay, so this is also a concept we will discuss in a while. What is log of odds ratio? So model dot coefficient, I am passing to that log odds ratio. I am creating instance here. Intercept, there will be one in intercept, so minus 0.1 in here intercept. Here I have created a data frame in which there are we have 21 independent columns, and against each column there are coefficient, like against age there is a coefficient minus 0.14, against credit amount there is coefficient, and in this way against each variable, each column there is some coefficient. Okay, and you know about the coefficient because you know about the logistic regression equation. Okay, now we will discuss the log odds ratio here, and how we can interpret, how um, we can use these coefficients for the sake of analysis on that on that particular data set, on particular attributes. Okay,